Good afternoon, everybody. Welcome again to our Bentley Success Factor Special Interest Group workshop. The topic of our talk today is about the seismic design using the multi-mode analysis and response spectra. Again, my name is Xin Lu. I'm the product manager for OpenBridge Concrete. As you might have, Sheree already mentioned, we are in the process of releasing the latest version of the OpenBridge Concrete Connect Edition version 17, which you may download and use in a week or so. The purpose of this workshop is to provide you a quick review of this new feature. At the end of this workshop, I hope you will have a clearer picture how the response spectral analysis works in OpenBridge Concrete. Here is our agenda today. First of all, I'll briefly talk about what response spectral analysis is. Then I will talk about how to do the response spectral analysis in OpenBridge Concrete. After that, I'll show you a demo of the response spectral analysis in OpenBridge Concrete. Then we will have the Q&A session. So what is the response spectral analysis? Basically, response spectral analysis is a linear analysis method which converts a problem in dynamics into an equivalent problem in statics. Response spectral analysis considers the contribution from each natural mode of the vibrations of structures and calculates the likely maximum elastic seismic response of that structure. And the response spectral analysis also provides insight into the dynamic behavior of by measuring the acceleration, velocity, or displacement as a function of a structure period for a given time history and the level of damping. So it is practical to envelope the response spectra so that a smooth curve represents the peak response for each realization of the structure period. So why we offer response spectral analysis in OpenBridge Concrete? Sheree also mentioned at the beginning. This feature is a major one we have been talking about for a long time. It is an advanced analytical tool of the seismic design for concrete bridges. So based on the feedbacks from our users, the response spectral analysis is one of the most commonly requested features in those regions. Particularly the AASHTO code has been adopted, such as in, of course, in US and other regions such as in Southeast Asia and Latin America. So for this release, we are going to offer the response spectral analysis for US code as well as Indian design code. So basically, we adopted this the solution of the response spectral analysis from another Bentley's key product, Stat Pro, and customize it and offer this advanced feature to our OpenBridge Concrete users. Basically, two major aspects needed to be considered in order to do this. In order to use the status solution for response spectral analysis. The first one is the mass modeling of a bridge model and the other is the generation of the appropriate design response spectra. Here is a typical workflow to do the response spectra analysis in LBridge Concrete. You build a full bridge model in LBridge Concrete first. Then the gradage model of this bridge you build will be internally created by LBridge Concrete. Then you can go to the Superstructure Module and making a necessary adjustment of the mass modeling table and run the analysis. After that, you need to go back to the main module of the LBridge Concrete, updating the full bridge model. Then you need to go to the Substructure Module, define the earthquake cases to generate the design response spectra. Then you need to define the other load types besides the earthquake loads and the related load combinations. Then you run the analysis. The next step would be you can proceed with the existing the routine of our LBridge Concrete to do the design check for all substructure components. Here is a typical beam slab bridge model created in LBridge Concrete. Here is the corresponding gradage model generated by LBridge Concrete. As I mentioned, this gradage model is internally generated and will be sent to the STAT solver for response spectra analysis. When generating this gradage model, LBridge Concrete basically follows the guideline provided by the final report of the National Cooperative Highway Research Program, NCHRP. The project number is 12-71, published in 2008. So after the full bridge model is built, so you need to go to the Superstructure Module. Two things you need to do in the Superstructure Module. So you can make adjustment as necessary to the mass modeling. Here you can see in the highlighted part, you can see the building mass tables are defined by the physical model you build it in the main module. Also, you have the option here to add extra rows to define the extra mass for the superstructure. Once this adjustment of the mass modeling is done, you can run analysis in this module, then exit this Superstructure Module and return to the main module and update the LBridge Concrete model accordingly. So the data brought back to the main module include the analysis of this Superstructure Module and as well as the mass table of this superstructure. Then you need to go to the Substructure Module, as shown here. First, you need to go to the Analysis tab, go to the Analysis and Design AD parameters. There, you pop up this dialog, and you can go. You can see under this Seismic AD parameter tab. So you need to choose the multi-mode response spectra analysis. The default number for the modes is 10. So you may use this default value or make adjustment as you need. And also there is some other seismic design parameters if you want to adjust that. Then you need to define the earthquake load cases and to create the related limit states. In other words, the load combinations. Next, you need to go generate the design response spectra. Here is an example for the US design code. Here you can see two options available. One is according to AASHTO code. Another is a custom option. If you select AASHTO, you will need to fill out the zip code here, and the latitude, longitude will be automatically shown, and the corresponding ground acceleration coefficients, such as the PGA here, S sub 1 will be derived from the National Ground Motion Database. The latest database for AASHTO we're using is 2014. Also, you can choose the custom option. When you choose this option, then the site this both the ground, the acceleration coefficient, and the site factor will be grayed out. You can see here, and the design response spectra table will open up here, so allowing you to manually input the data. The option is essentially allow you to use any design response spectra, for example, from different design code from other countries by using this option. Here you can see the 6 methods are offered to combine the response spectral analysis results. Those 6 options methods are a square root of the summation of the square method, so that is a SRSS, and also the absolute sum is ABS. Also the key CQC, the complete quadratic combination method. Also other 3 methods like a 10% method of a combined closely spaced method, some method particular for Indian code, the CSM, and other method code like a GRP, closed spaced modes grouping method. So you may specify the directions, the global directions in which the design response spectra is going to be applied. So this response spectra may be applied in one or more directions simultaneously. If the direction not applied, it will use 0 in the related for the related factors. Also, there is an option here shows that you can choose the dominant and the sign options. Those 2 options may be used in the input file to produce the signed output. If more than one direction is applied, the mode shape number is needed in order to use the sign. However, if only one direction is used and the mode shape, the mode number is 0, our stat solver will automatically find the mode shapes for which the mass participation is the highest and use that sign from that mode. Also, you may use the missing mass option to apply the missing mass correction. In other words, to include the static effect of the masses not presented in the modes. If this option is selected on any spectrum case, it will be used for all spectrum cases. After the design, a response spectra is specified and generated. The related load groups are generated. So the next step here is to run the analysis. To click this Run Analysis button here. What happens now is the mass table together with that graded model and the design response spectrum are sent to the stat solver to generate the response spectral analysis results for the whole bridge. In the meantime, the other load types, such as dead loads, live loads, wind loads, defined by you, are also sent to LBC Concrete its the own solver to generate the analysis results for the substructure. You can see here. So after this analysis process is finished, the results are brought back from the stat solver and reported under the analysis tab. The response spectral analysis results together with other analysis results due to other load types will be combined together based on the previously defined load combinations and used in the design check later. So how to check the response spectral analysis reports? Here is what you need to do. You can go to the Loads tab and select the earthquake. Select this earthquake node case and click EQ Details. So at the beginning of the report, so you will find the echo of the input parameters and the data for the design response spectra. You will see the ground acceleration coefficient and the soil types, side factors, etc. here. And if you keep looking, so you will find the mode frequencies of each mode and the mass participation factors in terms of the percentage. Also, you will find the mode-based actions and acceleration for an acceleration damping for each mode. If you want to see the response spectral analysis in graphic format, so you need to go use to click the diagram button in the ribbon, and from the LBC Concrete, and go to the response spectral analysis tab. Here are two examples of the diagrams for the mode shapes. So the left shows a mode shape 1, like this, and the right screenshot shows another mode shape number 5, like this. Here are another two examples of the diagrams for the vertical and the lateral forces. You can see here. So far, we have talked about the features of the response spectral analysis and use US design code, for example. And we also implemented this response spectra analysis for the Indian design code. The basic workflow is similar to the US code. Of course, the design response spectra according to Indian code is different from the Ashton code. And the load combination generation is also different. I'm not going through those details here. In the next session, I'll show a brief demo of how this response spectral analysis works. And let me bring the LBC concrete. I just opened the LBC concrete. This is our latest release. So as I mentioned earlier, you can download this. This will be available for all LBC concrete users in a few days. So let me open. In order to save time, I have some model. It's already built up here. So this is a typical slab beam bridges. So we are using the Ashton code here. So this is how these two span slab beam bridges look like. So we are going into the superstructure to check or make any adjustment as needed for the mass modeling. So we are going to the superstructure module. So we are using the design code LRFD7 with 26 rim. So this is some basic information here, the typical cross section and the beam layout. What we are doing here is the table included in our what we want to include in our response spectra analysis. So if you can see here is a tag here shows mass for response spectra analysis. When it's checked, this will be included in that mass modeling table. So there's some explanation here. So what's those nodes are? These nodes are stayed in place at deck form. This is a left barrier, right barrier. If you click this, it gives you the idea of what the input of the values, design values there. You can exclude and include. If you check this box, max for response spectra analysis, it will automatically include whatever you defined here in that mass modeling table. Once you have this, made all the adjustment, so you go to the analysis and run analysis. Then you finish the analysis part for the superstructure. And you can go back to, let's do another way. Then you can exit. Would you like to update the LBC concrete model? Yes. We don't need to generate design reports right now. Click no. So it finished the analysis of the superstructure. The next step would be go to the substructure. So we are going to do the response spectral analysis for this particular pier. So let's go to the substructure. Again, the first step is go to the analysis. Make sure we have this. Click the AD parameter, and under the seismic AD parameter, make sure you choose this multi-mode response spectral analysis and the default number is 10. So we are going to use 10 as default values. You can click this shows you some design parameters for the design check. This is the resistance factors. This is seismic overstrength factors. So we use just for demo purposes. We just use the default. Click OK. Then we go to the loads. In order to save time, I already generated some dead load here, and the live load be generated. So the next step would be generate the earthquake load. So we select this earthquake effect, and then we select that and click edit. So now we are at the in the dialog of, so we have two options: either use ASHTO 2014 at the database, or using the custom. So we are using the ASHTO code here. So we are using this is the zip code we are type in. So it automatically, when we type in, it automatically pop up those values. And we can use this. This is you need to specify the site class. We are using right now. We are using the class A. So those values are automatically pop up. Also, we are apply this response spectra in transverse. X is a transverse direction or in the global coordinate system of the bridge. So we are using the dominant mode. Also, the damping, we are using the default 5% for damping. After we have that set up, and the next step, we needed to generate the node groups. So we are choosing the strength 1 group, service 1 group, and we are choosing the extreme event group. So we go to the node combination. We can use the default node combination specified according to the ASHTO LRFD code. So it will generate all the default node combinations for those 3 node groups we choose. So we click OK. So we go to the analysis. Now we can run the analysis. After this analysis process is done, so we can check this is an individual load case. We can see the individual load cases analysis result for that particular pier. So this is this is a result for the self weight of that pier. This is the dead load we generated early, or individual live load cases. Now we can take a look at these earthquake cases. So this is the load effect returned from analysis results returned from our the stat solver, and provide the result for this particular pier shows here. So let's go to check some details of this response spectra analysis reports. So highlight this, click the view here, the details. So in this report, it shows you the echo of the input here, and this is the response spectra design response spectra data we are using here, and the mode frequencies, and the mass participation factors in terms of percentage, the base shear, and mode based actions, and damping, data, and also the model weight. All this under this, if you just click the EQ details. Also, if you want to see those results for the whole bridge in graphic format, you click this diagram, go to the response spectral analysis results. Let's go to the mode shape. You have scale here. Just scale up a little bit. So you will see different mode shapes. This is mode shape 1, 2, mode shape 3, and let's see 5 until 10. Also, you have the displacement accordingly. Also, it shows you the force. This is scale. Just put the scale down a little bit. So the force and the moment. I think with that being said, I think we've just I just give you a very brief demo to show how this response spectral analysis works in LBC concrete. So with that being said, I think I've just finished my presentation.
If you found this video helpful, please give it a like. If you want to see more such series, consider subscribing to our channel. Thank you, and see you next time.